Welcome to my mathematics class, class 6th, semester 2, fractions. By the previous video, we have completed the chapter fractions. Today, in this video, we will revise all the topics in the chapter fractions. So, first to define fraction, it is a part of the whole. Part of a whole. Let us suppose there is a pizza in circular shape. If we take a part, one piece, suppose it is made into 8 equal parts and we took one part. This is a fraction of the whole pizza, and this fraction is written as the total number of parts taken and the total equal parts made. So this part is 1 by 8. This is called a fraction. A fraction is a part of the whole. In this fraction, there are two parts. This one, that is the number above the horizontal line, is called numerator. Numerator. The number below the horizontal line is called denominator. Denominator. So if we take out two parts in this pizza, the fraction of the pizza taken out is 2 parts out of the whole. The whole is divided into 8 equal parts. Therefore, 2 by 8. So this is a fraction. In this fraction, 2 is the numerator and 8 is the denominator. Thus we can write, suppose we take out 3 parts. Then the fraction of the pizza taken out is 3 parts out of 8 parts. The fraction of the pizza taken out, 3/8. Thus we can write the fraction from a whole. Another example I will give. Suppose there is a square and it is divided into 4 equal parts and one part is colored. So the colored part is 1 part out of 4 equal parts. Total equal parts 4. So the colored part is 1/4. This is read as 1/4. 1/4 of the square is colored. 1/4. If 2/4 2 parts are taken, this is 2/4. If 3 parts are taken, that is 3/4. Like that, the fractions are written. A fraction is a part of the whole. ఒక whole బాడీలో ఆర్ ఒక లంసంలో కొంత పార్ట్ తీసుకుంటే దాన్ని ఫ్రాక్షన్ అంటారు. ఫ్రాక్షన్ ఈజ్ రిటన్ ఇన్ దిస్ ఫార్మ్. one number is above the horizontal line and one number is below the horizontal line. The number above the horizontal line is called numerator and the number below the horizontal line is called denominator. And the fractions are divided into 2 types. One is like fractions, and the other is unlike fractions. That is, if the denominators are same, the fractions are called like fractions. For example, 1 by 4, 2 by 4, 3 by 4, 4 by 4, etc. are called like fractions because the denominators are the same, or 2 by 5, 4 by 5, etc. The denominators are same. These are all like fractions. If the denominators are not equal, like this, 1 by 5, 2 by 3, 8 by 9, etc. Here the denominators are 5, 3, 9, etc. different. Therefore such fractions are called unlike fractions. Unlike fractions means fractions whose denominators are different. Unlike fractions. Now we will see how to write equivalent fractions. What is an equivalent fraction? For example, 1 by 2 is a fraction. In figure, This is divided into two equal parts and one part is taken. This is 1 by 2 because one part out of two parts. Therefore 1 by 2. Suppose it is made like this, divided into four parts and two parts are taken. This is written as this part, shaded part is written as two parts out of four. But the portion is the same. When it is divided into two equal parts, we have written it as 1 by 2. When it is divided into four equal parts, we have written it as 2 by 4. Therefore, these two are equivalent fractions. We can write the equivalent fractions by multiplying the fraction, one fraction, both numerator and denominator by the same number. Suppose if it is multiplied by 2, 1 into 2, 2 into 2. We get 2 by 4. 2 by 4. Therefore, 2 by 4 is called an equivalent fraction of half. Similarly, 1 into 3 by 2 into 3. That is equal to 3 by 6. This is also an equivalent fraction. If we multiply both numerator and denominator by 4, we get 4 by 8. This is also an equivalent fraction. Thus we can write as many equivalent fractions as we can. Then, but all these equivalent fractions can be converted into its simplest form again. For example, 4 by 8 is an equivalent fraction of 1 by 2. Just now we have seen. But 4 and 8 are divisible by 4. Therefore, if we divide both numerator and denominator by 4, we get 1 by 2. 1 by 2. We cannot simplify 1 and 2 still further because there is no common factors for 1 and 2 except 1. So if there are factors, common factors for numerator and denominator other than 1, we can divide both by that common factor. If there is no common factor, that is the simplest form of the fraction. Simplest form of the of that fraction. Next, again, for unlike fractions also we can write equivalent fractions. Suppose 2 by 3, 4 by 5, etc. These are all unlike fractions. But we can write for any fraction, we can write equivalent fractions by multiplying the both numerator and denominator with the same number. Or if the numbers are more greater numbers, suppose 200 by 300, we can divide it by any number, any common number. 200 common factor, we can take any common factor of 200, 300. There are so many common factors for 200 and 300. 2 is a common factor. 200, 2 ones, 2 5s, 0. And 5 is a common factor. 5 2s, 0, 5 3s, 0. And 10 is a common factor. 10 2s, 10 3s. So we can divide by any number, we will get an equivalent fraction of 200 by 300. So to find the simplest form of the form of a fraction, we have to go on dividing by a common factor until we get there is no common factor except 1 for both numerator and denominator. Next, to compare two fractions, comparison. Suppose there are 1 by 2, 3 by 2, 5 by 2, etc. Like fractions. In the like fractions, the fraction whose numerator is greater is great. So here 1, 3, among 1, 3 and 5, 5 is the greatest. Therefore, 5 by 2 is the greatest among these 3. Next 3 is greater, therefore 3 by 2 greater than 1 by 2. Thus, we can easily say, just by looking the fractions, which is greatest and which is smallest. But in the case of unlike fractions, so unlike fractions means 1 by 2, 1 by 3, 1 by 4, 2 by 5, 5 by 5, 5 by 6, etc. Denominators are different. Therefore, we cannot easily compare the unlike fractions. We have to take the LCM and write the equivalent fractions and made them or convert them into like fractions. Then we have to compare by comparing the numerators. But if the numerators are same, for example, they are like this 1 by 2, 1 by 3, 1 by 4, 1 by 5, etc. like fractions whose numerators are same. When the numerators are same in unlike fractions, the fraction whose denominator is greatest is the smallest. The fraction whose denominator is the greatest is the smallest. The fraction whose denominator is smallest is the greatest. Therefore, here 1 by 2 is greatest. So, greater than 1 by 3 is greater than 1 by 4 is greater than 1 by 5, etc. But if the numerators are different, both the numerators and denominators are different, we have to compare them in some other method, writing equivalent fractions, taking LCM, etc. We will see it later. This is comparison. On comparison, we can write them in order. Next, to compare the unlike fractions, suppose 1 by 2, 1 by 3. Two are unlike fractions. We can easily say that as the numerators are same, the fraction whose denominator is lesser is greater. The fraction whose denominator is greater is lesser. Just now we have seen. But suppose it is 2 by 3. Numerators are different. We have to write the equivalent fractions. Let us suppose 1 by 2. Multiplying both numerator and denominator by 2, we get 2 by 4. Next, by 3, multiplying by 3, 3 by 6. Multiplying by 4, 4 by 8. Multiplying by 5, 5 by 10, etc. We can write many. Similarly, for 2 by 3, multiplying by 2, 4 by 6. That is equal to multiplying by 3, 3 2s 6, 3 3s 9. Multiplying by 4, 8, 12. Multiplying by 5, 10 by 15, etc. Now, we will identify the like fractions in these two. Here 6 is there as denominator in these like fractions and these like fractions also. So 1 by 2 is equal to 3 by 6, 2 by 3 is equal to 4 by 6. 1 by 2 is equal to 3 by 6, 2 by 3 is equal to 4 by 6. Which is greater? Here these two are like fractions. So denominators are same. So compare the numerators. Here 4 is greater than 3. Therefore 4 by 6 is greater than 3 by 6. That means 2 by 3. 4 by 6 is equivalent to 2 by 3 is greater than 1 by 2. Suppose if the denominators are very large, as the denominators are very less, we have written a number of equivalent fractions and compared. But if the number is very large, we have to take the LCM, least common multiple of the denominators. For example, 5 by 9 and 7 by 11. 5 by 9 and 7 by 11. How do you compare it? By writing the equivalent fractions, it takes a lot of time and we have to write a lot of equivalent fractions. So we have to find the LCM. LCM of 9 and 11. So in the division method, if there is any common factor, For 9 and 11, we have to divide it like this. But for 9 and 11, there is no common factor. Therefore, we can't divide it other than 1. Therefore, LCM is equal to 1 into 9 into 11. So, 9 into 11, 99. 99. So, 99. We have to convert this into an equivalent factor having 99 as the denominator. So, if you want 99 here, we have to multiply it by 11. 5 into 11 by 9 into 11 is equal to 55 by 99. Similarly, we have to write this fraction also into an equivalent fraction whose denominator is 99. So to get 99, we have to multiply it by 9. How did we get that 9? Divide the LCM by the denominator. 99 divided by 11 is 9. So multiply 7 by 11 into 7 into 9 by 11 into 9, which is equal to 7 9 63 by 99. Now we got the equivalent fractions for these two fractions whose denominators are same, like fractions. We got two like fractions. Now we can easily compare whose numerator is greater is greater. So 63 by 99 is greater than 55 by 99. But 63 by 99 is equivalent to 7 by 11. So 7 by 11 is greater than 50 by 99, which is equivalent to 5 by 9. Thus we can compare the unlike fractions. If the unlike fractions have the same numerator, we can easily compare as seen before. But if the numerators are also different, we have to take the LCM of the denominators and convert them into like fractions and compare them. The numerator whose numerator is greater, like that. Next, additions of fractions. First we will see additions of like fractions. Suppose 1 by 3 plus 2 by 3. 1 by 3 and 2 by 3 are like fractions. Therefore, it is very easy. The same denominator is taken as denominator and the numerators are added. So 1 plus 2, 3 by 3. 3 by 3 is equal to 1. Or 2 by 5 plus 1 by 5. These two are like fractions, therefore same denominator will come and the numerators are added, 3 by 5. Thus, like fractions can be easily added, adding numerators and taking the denominator as the same, like that. But coming to the unlike fractions, we have to take the LCM. Suppose 1 by 5 and 2 by 3 should be added. 1 by. Here 5 and 3 are two different numbers. 5 and 3. There is no common factor for 5 and 3. Therefore, LCM is equal to their product. 5 into 3 is equal to 15. Therefore, write 15 as the denominator. Divide 15 by 5. You get 3. Then multiply 1 by 3. 3 ones 3 plus divide 15 by 3, you get 5. Multiply 2 by 5. 2 into 5s 10. That is equal to 13 by 15. Thus we have to take the LCM of both. We will take another example, 1 by 6 plus 3 by 8. 1 by 6 plus 3. Here 6 and 8 are the denominators, they are not same. Therefore, we have to take the LCM by division. Both are divisible by 2. Therefore, 2 3 6, 2 4. And then again they are not divisible by any number other than 1. Therefore, LCM is equal to 2 into 3 into 4. 2 3 6. 6 4s 24. So, 24 is the LCM. So, 24 comes as denominator. 24 divided by 6 24 divided by 8 is 3. 8 3 is 24. Multiply 3 by 3. That is equal to 4 plus 9 by 24 or 13 by 24. Thus, we have to take the LCM of the two denominators and simplify. Similarly, in the case of subtractions also, in the place of plus, we get minus. In like fractions also, in the place of plus, we get minus. No difference, just the simple. Instead of adding the numerators, we will subtract. That's all.